Right, so let's look at this one. Okay, we're going. So if we have a polynomial, let a polynomial be p of x, we represent a polynomial with p of x, and then also let x minus a be a factor, okay, of this polynomial, definitely. Meaning that if it's a p of x, that polynomial divided by that factor, supposed to give you a quotient, yeah, which is a function of x, q of x. We call it q of x. Yeah, then plus a remainder p of a. Yeah, yeah. So this simply means that in looking at the previous example that we had our p of x is simply the x to the power 3 plus x squared minus 4x minus 4. This is our p of x. That's the polynomial that we are dealing with. Now, and then the factor that we have that we've been given is simply x minus 2, the one that we are, meaning that our a is simply what? 2. A here, a here is a number, okay? Then x is a variable. Yeah, don't confuse these two. A is a number. You can put q, you can put any letter here, but for simplicity, just choose a. Yeah. Now, if this is a factor of this polynomial p of x, we're supposed to get p of a, which is the remainder, as 0. If it's a factor of this, if x minus a is a factor of p of x, then the remainder p of a is simply a 0. Yeah. So we can prove this using a synthetic division. This is the equation that you have. We are dividing this polynomial by the factor x minus 2. So the first thing, just let x minus 2 be equal to 0, and then so for x, you have x equal to 2, that the one I'll put here. Then from the equation that you are dividing, only get the coefficients only. So here you have a coefficient of 1, this is the one here. Here you also have a coefficient of 1, this is the one here, coefficient of minus 4, this is a minus 4, also here minus 4, minus 4 here. It's a constant, yes. So you just definitely drop the 1 here, the number which is here, put it down here. So meaning that now you multiply this by this, so we have 1 by 2, which is 2. We write it here. Then after that, here, in case you are confused, we just get this value, drop it down here, then now multiply this value by this, so mean that we have 1 times 2, which is the 2 here, the one that we write. Then now from here we add this plus this, we get a 3. Yeah, 1 plus 2, we get a 3. Then so we get 3 by 2 again. So 3 times 2, we're going to get a 6. This is the 6 here, don't be confused. So 1 plus 2, we're getting a 3. 3 times 2, a 6. Again, 4, which is here, it's a minus 4 plus 6, we're getting a 2. Minus 4 plus 6, we're getting a 2. Then 2 multiplied by 2 again here, we're getting a 4. Negative 4 plus 4, definitely a 0 here. This is the remainder, p of a. So here the quotient reduces by the powers of x reduces by 1. So here it was x to the power 3, it has now reduced to x power 2. This line, it was x power 2, it has reduced to x. This line was x, it has just reduced to a constant. This one's a 0. Yeah, definitely. It is simply, therefore, we have q of x, this one. P of a is this, the remainder 0. Meaning that now our p of x, the one which is here, is simply this value multiplied by this, or which in this case we are dealing with polynomials, it's the whole of this polynomial by the factor, which is x minus 2, or you can swap, the factor comes in front and then the other one at the end. If you multiply these two, you're going to get this value here, which is a polynomial of x, and the 0 here, I've added it because it's a remainder to show you that the remainder is 0. So if you're getting the remainder to be 0, that means you've shown that indeed x minus 2 is a factor of x power 3 plus x squared minus 4x minus 4.